Hello everyone, we are going to lecture 17, Comparing Distribution. I'm your instructor, Ms. Laura Lowe. We are in week 7. This week we will talk about distribution and decision making and also introduce A/B testing. In today's lecture 17, we will compare distribution and introduce hypothesis testing. In lecture 18 and 19, we will talk about more how to do the decision making according to the visualization, and also talk about A/B testing and more hypothesis testing example. Before talk about the new topic from this lecture, let's review what we have from lecture 16. Remember we talked about how to accessing models. So the model is a set of assumptions about data. In data science, we call that the chance model because many models, they involve assumptions about processes that involve the randomness. So after we have the model, the most important thing we want to ask is, does the model fit the data well? So the key question also is doing the hypothesis testing. What does that mean? That's about approaching of the assessment. If we can simulate data according to the assumption of the model, we can learn what the model predicts. We can then compare the model's prediction that's from our simulation. Remember, our simulation is repeated simulation with large amount of time. From this result of our simulation, we will compare the data we observe. So that's the most of the time we just make a visualization, maybe the histogram from this 1,000 or over 1,000 times simulation result. Then we also plot the set of observation data results. Then we compare. If the observed data falling in the area we think that's it, is located the area we can accept from the simulation result, then we can say the data and model prediction are quite consistent. Then that means our model is doing well to fit, to explain our data. On the other hand, if our observed data is kind of out of the acceptance area from the simulation result, then we can say the data and the model's prediction are not consistent. So that's evidence against the model. So that we call the hypothesis testing. If the evidence against the model, we either need to just reject the model, or you can modify the assumption. Then you need to redo the simulation. Then we see the result again. So that's the assessment about the models. So usually the hypothesis testing we talk about is we have the two viewpoints. One is the model, one is alternative. So according to the model, then we will see can we accept the alternative or not. So hypothesis testing here, we will give you the two examples we have from the lecture 16. To see how to do the hypothesis testing. Then you will see the two viewpoints from each example. So the example, our first example is the legal example about the jury selection for our superior court, right? So the model suggests, is the people on the jury's panel were selected at random from the eligible population. So that's why according to this assumption, then we repeat it do many times to do our simulation. So then we using the results from our model simulation. So then we compare the one result, like the Roberts case. Then you see they have 8%. The jury panel is 8. Yeah, so they only have 8% from for the black jury's candidates. So that's why we see they are outside the can be accepted from our model simulation result. So that's why here the two viewpoint is the model viewpoint. Then we have the alternative viewpoint. So no, they were biased against black men. So according to the result we compare, then we can find out because the observed data is really outside the model simulation's most range. So we know we cannot accept the models. So instead, the alternative viewpoint is the result. So no, they were biased against the black men. So that's one example about the hypothesis testing. When we do the simulation, the first thing, of course, our viewpoint, the first viewpoint is according to the model. Then the second one is the alternative viewpoint is the model against the evidence of the model against what we observed. So see the second example, the genetics example from Mendel. The model suggests each pea plant has 75% chance having purple flowers. Now that's his model because he said that's 75%. So that's why in our alternative viewpoint will be opposite from the model. So that's not 75%. So that's the reason when we simulate our model, we do many times, but one thing is when we really compare the simulation result with the observed result. So because they say purple flower chance is 75%, then our observed data, I think that's 9, I forgot exactly the number, but out of 929, that's the observed data. So then we compare the 75, so they are not matched. So that's why we will accept the alternative viewpoint. So no, it does not. So you need to be careful is this example is very straightforward, they say, because they say each plant has 75% chance. So that's why we just compare the difference from the observed data result with the 75%. So to conclude what we have, so whenever we have a model, we need to assessing the model. So here's the step. So the first thing you see what the model is, then we will choose a statistic to measure the discrepancy between the model and observed data. Then we simulate the statistic under the model assumption. That's very important. We need to meet all the model's assumption. Then we run a large amount of time. Then we compare the observed data to the model's prediction. So for the categorical data, we draw a histogram of the simulated value of the statistic. Then we compare the observed statistic from the real sample. If the observed statistic is far from the histogram, the evidence is against the model. So that's a quick review what we have from lecture 16. So after you understand assessing model, then I want you guys to have the discussion question. Here we have two discussion questions, basic with the same concept. So in each A and B, please discuss with your group, your peer group. Choose a statistic that will help you decide between the two viewpoints. So the observed data, so usually we just say data, that's the observed data, will be the result of 400 tosses of a coin. So that means we just we toss the coin 400 times. So then the first discussion question, the model is the coin is fair. So the alternative viewpoint will be no, it's not. So the second question, the model is still the same, is the coin is fair, but the alternative viewpoint is no, it's biased toward heads. So before you go to see the answer, or the next few pages of our lecture file, please make sure pause the video, discuss with your peer group for a couple minutes before moving forward. Okay, so I want you to make sure you will think about that before you see the answer, because those kind of questions will be in your midterm exam as well. So you need to understand how to answer that. Okay, so now I will assume you already discussed with your peer group or any classmate. So we're moving forward. So for both A and B, because we talk about is the coin is fair. So that's why the percentage of the heads in the 400 tosses is a good start point, but might need to be adjusted. So that means to be a fair coin, that means after the 400 toes, then the heads, the chance for the heads will be close to 50%. Okay, so the first beginning, of course, we will have the outcome actually for each, we have the heads or tail outcome. So then if we simulate for 400 toes many times, so each time actually they should be close to 50% for the heads. So our model state for the coin is fair. So that's why we want to run the simulation in a large amount of time of the experiment to toss the coin 400 times. So then we want to see the result for the heads should be close to 50%. So back to our discussion question. Because our discussion question, the first thing is the viewpoint just say is not. Okay, so no, if this viewpoint is not, that means the head result is not close to 50%. So on the other hand, in the distribution, if you have very big chance or very small chance of the heads, they are suggest it's not fair. For example, like 10% heads only, or 90% heads, or 90% heads. Either one, they are not fair. But that's really big amount. So the distance between the percent of the heads from the 50% actually is what we want to observe. So that's like the genetic example we have. So from here we say the distance that's they may be greater than 50%, they may be less than 50%. So the statistic will be the percentage of the heads subtract from 50%, but we take the absolute value. So then you will just see if the observed result will be the great value of the statistic. What we are calculate, they will be not fair. So large value of the percent of the heads suggests bias toward to the heads. So that's the discussion question A. So it's better choice for the statistic we just choose for the distance between 50% and the heads percent. But the second one, so the B, we back to see the B again. So the B, still the model we say the fair is, the coin is fair. But the viewpoint, alternative viewpoint is biased towards to the heads. So that's why in your B, we are not necessarily need to find the distance. Instead, actually, we can just consider about the percent of the heads. If the percent of heads close to 50%, so yeah, I think the model kind of described well. Okay, so then the model is fair. But if that's far from the 50% from your observed data, then we will say they are biased toward to the heads. Of course, when we say far from the 50% is like 70%, 90%, or 80%. If they are smaller one, it's not the same thing. Is not biased toward to the heads. So the statistic we can use is the percent of the heads. So you can see I have screenshot for the answer sheet for referral to, but after discuss with your classmates. So try on Jupyter Notebook.